Assalamualaikum and very good morning to everyone. Today, I want to welcome all of you to Module 2 of Basic E&P Training. We will be exploring further on upstream oil and gas business. In the last module, we stopped at appraisal stage of life cycle of oil and gas fields at the appraisal well logging. Today, we will continue on appraisal activities as shown in the content in the next page. These are the subjects that we will be going through in this module 2. Firstly, we will be learning reservoir evaluation during appraisal stage. Then we will be going through the economic evaluation and followed by drilling operations. Within drilling operations, we'll be introducing to you classification of well types, rig components, drilling sequence, horizontal and directional drillings, well completion. We conclude drilling operations by working through with you on wellhead and Christmas tree. We will introduce to you today the Field Development Plan or FDP, and we will learn reservoir engineering in FDP, development wells locations, development production forecast, and development concept. And one of the interesting development concept, which is subsea, will be discussed in this module. Reservoir evaluation. The volume of hydrocarbon in reservoir can be calculated directly by volumetric methods, indirectly by material balance methods. Volumetric provides a static measure of oil or gas in place. Accuracy of volumetrics depends on data for porosity, net thickness, areal extent, hydrocarbon saturations. Material balance methods provide a dynamic measure of hydrocarbon volumes. Accuracy depends on quality of data for pressure surveys, temperature surveys, and analysis of recovered fluids. Normally, mass balance methods increase in accuracy as the reservoir is produced. The purpose of reservoir evaluation is to establish a suitable reservoir classification and evaluation method through the analysis of the actual geological conditions of the reservoir, so as to provide a reliable and important basis on the development of oil and gas fields. Reservoir performance is the ability of a reservoir to produce hydrocarbons at a desired rate and quality, and can be measured by indicators such as the recovery factor, reservoir pressure, productivity index, and water cut. The oil and gas field evaluation aims to develop oil and gas fields. One of the methods used is the volumetric calculation to estimate oil and gas reserves. By estimating reserves, we can estimate the potential value of oil and gas resources to fulfill energy needs. Original oil in place refers to the total volume of oil stored in a reservoir prior to production. Gross rock volume, GRV, represents a volume estimation above a known hydrocarbon water content. Net to gross ratio is the fraction of reservoir volume occupied by hydrocarbon-bearing rocks. Oil saturation is the fraction of porosity of a zone occupied by oil. 1 over formation of volume factor, BO, is shrinkage, which is the volume change that oil undergoes when brought to the surface. Original gas in place refer to the total volume of gas stored in the reservoir prior to production. Gas saturation fraction or percent of pore volume occupied by gas. 1 over Bg is shrinkage, which is the volume change that the gas undergoes when brought to the surface. Formula to calculate volumes of oil or gas is stated here. Volumetric estimates provide a static quantity of initial hydrocarbons in place. The precision of these quantities are greatly dependent on the amount of data the geoscientists have obtained. In the early phases of development, the data of a potential reservoir is limited, and volumetric estimate is based on the accuracy of the parameters such as GRV, reservoir geometry and trapping, pore volume, permeability, and fluid contacts. Once the phases of appraisal continue and drilling operation begins, the accuracy of the volumetric estimation will increase. The purpose of calculating volumetric estimation is to evaluate a reservoir and calculate the potential reserve of the reservoir. Once drilling has started, pressure and production data is collected, giving a greater insight into the volume that needs to be evaluated. Appraisal drill stem testing. Drill stem testing is a procedure to isolate, simulate, and flow a downhole formation to determine the fluids present and the rate at which they can be produced. Oil, gas, and water produced is separated in a test separator. Each outlet is measured and the gas-oil ratio and the percentage of water content is calculated. A DST is a temporary completion of the well. Drill stem tests are usually made for the following reasons. Number 1, to determine the producible fluid content of formation. And number 2 is to determine the ability of formation to produce. Although a DST can be performed in the uncased hole, which is open hole, or in cased hole perforation test, the open hole test is more common. Well test analysis. Well testing is a significant step toward qualitatively and quantitatively characterization of hydrocarbon reservoir. Information provided is important for estimating the reservoir productive capacity and average pressure. Well test analysis also provide the analysis of reservoir performance and predicting its future production. Well and formation tests, which entail taking measurements while flowing fluid from the reservoir, are conducted at all stages in the life of oil and gas fields, including appraisal stage. Operators perform these tests to determine whether a formation will produce hydrocarbons at a rate that gives a reasonable return on investment. Operators also use test data to determine the limits of the reservoir and to plan the most efficient methods for producing wells and fields. Well and formation tests are also primary sources of critical data for reservoir models and are the principal means by which engineers confirm or adjust reservoir model parameters. Engineers use these models to understand how reservoir fluids, the formation and the well interact, and use that knowledge to optimize completion and development strategies. Petroleum economic evaluation. Some important items in the economic evaluation would be expected recoverable reserve, expected price of petroleum, expected cost of exploitation, expected profitability, expected risk and contingency. The purpose of petroleum engineering is to examine, define and implementing methods and procedures for developing and extracting oil and gas so as to optimize profits and obtain a return on investment that is commensurate with the risk incurred in making the investment. Most of the oil and gas development projects will have initial production data available. Thus, in these circumstances, production decline curve analysis can be used to aid in overall estimation of recoverable reserve of oil and gas. To forecast the overall risk and return on investment for a proposed oil and gas field development requires a study of and forecast of what oil and gas market price will be in the future. In order to obtain adequate development project costs or exploitation costs on top of cost estimation, the production volume from the target reservoirs need to be estimated. Statistical databases are important tools used for application of risk analysis techniques to allow for a distribution of cost and return on investment for petroleum development projects. Petroleum economic analysis will present a complete risk analysis leading to net present value (NPVs) of the oil and gas field project. The analysis goes through each step of a typical economic projection, i.e. price forecast, recoverable volumes, projection of future production, cost of development elements in the project, and ultimately the NPV distribution outcomes. Oil and gas project economics. Project economics play a crucial role in determining the success of such projects. In the evaluation process involves four stages: during exploration, appraisal, development, and production. The appraisal stage involves the evaluation of discovered resources, reserve estimation, and flow testing. Financial modeling is an essential aspect of oil and gas project economics. It determines the feasibility of the project and assesses its profitability. Financial models consider various factors such as capital expenditure, operating expenses, and revenue projection. Sensitivity analysis helps in assessing the impact of changes in key parameters on the financial viability of the project. Risk analysis is another critical aspect of oil and gas project economics. Risk can arise from various factors such as geological uncertainties, technological challenges, market fluctuations, and regulatory changes. Monte Carlo simulation is a commonly used risk analysis techniques that helps to quantify and manage the risk associated with the project. We will go through another economic evaluation process during the development stage in the next module. Ladies and gentlemen, that are all we have for today's session. I hope you have learned something beneficial today. In our next session, we are going to learn about drilling operation. Until we meet again in the next session, Have a nice day. Thank you.